In 1997, a sound from the ocean shocked scientists, and no one knows what caused it. Imagine the vast, silent darkness of the deep sea. It is a world of immense pressure, cold, a place far from the sun's warm light. Down there, sound travels differently. It moves farther. It carries secrets. For years, scientists have placed listening devices on the ocean floor. They are called hydrophones. These sensitive instruments are our ears in the abyss. They listen for the songs of whales and track the rumble of distant earthquakes. But on a particular day in 1997, they recorded something else entirely. Something unexpected. The signal was sudden. A bright, sharp line of sound that cut through the deep. The noise was incredibly loud, very low in frequency, a deep hum that vibrated through the water. It was not the familiar signature of a passing ship, nor the biological chorus of known marine life. This sound was unique. It possessed a strange and specific pattern. It rose in frequency, then fell away into silence. The bloop was detected by multiple hydrophone arrays across the Pacific Ocean. Some sensors were separated by more than 5,000 kilometers, or 3,000 miles. Louder than any noise they'd classified. Louder than a blue whale. Louder than most underwater volcanic eruptions. A mystery was born, captured only as a ghostly trace on a computer screen. This single one-minute recording sparked a debate that has lasted for decades. It captured the public's imagination and fueled endless speculation. The story spread far beyond the quiet labs of oceanographers. It became a modern legend of the sea. It was a question posed by the ocean itself, a question that scientists are still trying to answer today. Well, on this very day, October 20th, 2025. The discovery of the bloop was not an isolated moment of chance. It was the product of a secret, large-scale military project. During the Cold War, the U.S. Navy deployed a vast network of underwater listening posts across the world's oceans. This system, known as the Sound Surveillance System, or SOSUS, was designed to detect and track quiet Soviet submarines. After the Cold War ended, the Navy's top-secret tool found a new purpose. In the early 1990s, the system was declassified. Oceanographers were granted access, like being given a new sense, a way to hear the planet's heartbeat. They began using the SOSUS arrays to study undersea earthquakes and volcanoes, and to track the long-distance migrations of great whales. It was within this new scientific context that the bloop emerged, in the summer of 1997, as researchers analyzed data from the Pacific arrays. They were looking for the usual sounds of the sea, but the anomalous signal appeared, unlike anything in their extensive library. The signal's unique frequency profile, which rises and then falls, was its defining characteristic. It sounded almost like a bubble rising through water, the bloop. Recorded, cataloged, flagged for further investigation. A single data point that demanded an explanation. The timeline was precise. The data, clear. The hydrophones, operational. A real, physical event, preserved in NOAA's digital archives, became a scientific puzzle. The first step in solving the mystery was to find out where the sound came from. Locating a sound source in the vastness of the ocean relies on triangulation, measuring tiny differences in arrival times across far-flung hydrophones. Using this method, NOAA narrowed the bloop to a remote spot in the South Pacific. Roughly 50 degrees south, 100 degrees west, a desolate, forbidding part of the world. Thousands of miles west of South America's southern tip. Antarctica, the closest landmass, far to the south. Rough seas, powerful storms, deep cold waters, far from major shipping lanes and human activity. The middle of nowhere. Geologically active, part of the Pacific Ring of Fire. Yet the exact origin did not match any known underwater volcano. Near the Antarctic Convergence, a dynamic zone where massive icebergs sometimes drift. The puzzle deepened. Rather than ships and subs, the search took place in labs, scouring bathymetry, reviewing seismic data, and comparing the bloop to every known source, industrial and biological. What did the bloop actually sound like? Converting the audio into a spectrogram revealed a distinct, unusual shape. a narrow band rapidly increasing in frequency over about 1 minute, then fading. When sped up to be audible, it is a strange, resonant noise, a deep underwater gurgle, like a massive bubble breaking the surface. The rising frequency made many think biological, a structured call, while geological noise usually lacks such orderly modulation. But the most startling aspect was amplitude. The bloop was several times louder than the loudest recorded blue whale call. For a creature to make that, it would have to be colossal, a true leviathan, leaving scientists with conflicting clues. The profile suggested an animal, the volume suggested planetary forces. The graceful shape pointed to life, the raw power to shifting ice or volcano. The data was clear, but the story wasn't. The most captivating theory, the one that seized the public's imagination, was that the bloop was the sound of a colossal, undiscovered sea creature. The ocean is vast and largely unexplored. We know more about the moon than the deepest parts of our own seas. Every year, scientists discover new species. So a gigantic animal surviving in the abyss isn't impossible. Proponents pointed to the sound's organic, structured nature. It sounded alive. This taps into our ancient fascination with sea monsters, krakens, and leviathans. Could it be an oversized squid, a surviving prehistoric reptile, or a new type of whale, larger and more powerful than the blue? Scientists remained skeptical. To produce such a sound would require near impossible size and energy, and leave ecological traces. No repeat recordings from the same spot, no washed-up giant, no submersible footage. Romance without proof is speculation. For most scientists, the cry of a leviathan raised more questions than it answered, pushing the search toward a more plausible, if less dramatic, solution. Section 6, Theory 2. The groan of ancient ice. A grounded theory proposed the bloop was not biological, but geological, the cracking and fracturing of a massive iceberg, a cryosysm, an icequake. When a gigantic piece of ice breaks away, or scrapes the seafloor, it releases tremendous acoustic energy, low frequency, extremely loud, traveling vast distances in the deep sound channel. The origin lies along routes where icebergs drift from Antarctica, some the size of small countries. As they melt, move, and break apart, they produce a symphony of strange sounds. Dr. Christopher Fox and NOAA deployed autonomous hydrophones to monitor ice, discovering iceberg breakups with spectrograms strikingly similar to the bloop. These icequakes show rising frequency, immense power, basin-wide propagation, building a consensus over time. Subsequent detections were confidently linked to specific calving and disintegration events in the Bransfield Strait and the Ross Sea. Not a monster, but the groan of a dying mountain of ice, supported by evidence and observation. Section 7. Theory 3. The Earth's fiery breath. The origin lies in an active tectonic region, where ridges, trenches, and seamounts reshape the seafloor. Submarine earthquakes and eruptions release enormous energy and loud low-frequency sounds that travel efficiently underwater. However, seismic signatures are abrupt and broadband, unlike the bloop's slow, structured upsweep, and no matching event appeared in seismometer records. Seafloor surveys found no evidence of a recent major eruption at the pinpoint. While geology could explain the power, the profile fits icequakes better. The Earth's fiery breath seemed to sing a different song. Section 8. A Symphony of the Strange. The bloop. Not the only unexplained ocean sound. Julia. March 1, 1999. Intensely powerful. About 15 seconds, heard across the equatorial Pacific. Likely a large iceberg running aground off Antarctica. Slow down. May 19, 1997. A 7-minute sound slowly decreasing in frequency, traced to Antarctic ice. Upsweep. First detected in 1991. Narrow-band upsweeps, seasonal peaks in spring and autumn, possibly volcanic or hydrothermal. The deep sea is not silent. It is full of rumbles, groans, and calls. Valuable clues for climate, geology, and life at the edges of our maps. These mysterious signals are valuable scientific data. The lingering question. Today, October 20th, 2025. Official consensus. The bloop equals icequake. The evidence is compelling. Acoustic signature matches ice-related events. Immense power consistent with fracturing ice. The location fits Antarctic iceberg routes. For most researchers, the case is closed. Logical. Evidence-based. And yet, a small, persistent whisper of doubt remains. The icequake theory fits, but it's not perfect. The bloop is similar to icequakes, not identical. The exact iceberg was never pinpointed. The deep sea holds its secrets close, a world vast and alien that may still harbor profound surprises. Imagine the consensus is wrong. Imagine something else made that sound, something vast, ancient, alive. It called once, then silence. What really made the bloop? Subscribe for more interesting facts.